So we'll see about the very important concept, alligation. So by using this alligation, we can solve out the questions by avoiding all complex working. So we can use this alligation when two types of data is given to find the ratios. So now we'll see a simple example how to apply this alligation concept and work out the question. Say for example, so in this question, a factory has only engineers and workers. The average salary of engineers is rupees 1200 and the average salary of workers is rupees 500. The average salary of all is rupees 800. What is the ratio of engineers to workers in that factory? So now we'll see the working of this question. So first we'll see how to do the working and then we'll use the alligation concept. So how simple we can get the ratio or the required answer. So in this factory you have only two categories, engineers and workers, and average salary of engineers is 1200. So to find the sum of salary given to the engineers, we have to multiply the number of engineers into the average salary. So engineers will take as number of engineers as E, and to find the sum of salary given to the engineers, so this into 1200. So multiplying the number of engineers into their average salary, you get the amount given to the engineers. And let me take the workers as W. So to find the amount given to the workers, so that is number of workers we take as W and their average salary is 500. So by multiplying that, so number of workers is W and their average salary is 500. So to find the total salary, so we add. So this will be equal to, so now number of persons in this factory is E plus W, that is the number of engineers and the workers. So number of persons is E plus W into their average salary, so which is given as 800. So in this question, you are asked to find the ratio of engineers to workers. So by expanding this and bringing all the single variable to one side, so either we can take engineers on left hand side, workers on the right hand side, and we'll get the ratio. So but this takes time to work out. So we'll see how to get this ratio by applying the alligation process. So while applying this alligation process, so you can either write engineers first or workers first. So we'll write here engineers and the workers. So under them we'll write their average salary. And average salary of workers is 500. So overall average salary will always lie in this region only. That is, it will be more than 500 and it will be less than 1200. So here we have average of all is 800. That is the median value right in the middle. Now instead of multiplying, expanding and bringing all variables to one side, so writing in this pattern, so you just subtract 800 from 1200, which is equal to 400. So subtracting the median from the highest, we get 400. So which will be equivalent to this workers part. And now for this side, so subtract the lowest value from the median, that is 800 minus 500. So which is equal to 300. So now we are asked to find ratio of engineers and workers, but by just simplifying this difference, so you get the ratio of engineers and workers as 3:4. Suppose if it is written as workers first and engineers second, so we'll get it as 4:3. But our question is ratio of engineers to workers. So see that the engineers is written first. Engineers to workers ratio is 3:4. So by using this alligation, we have easily found the ratio by avoiding all this workings. So now we'll see the shortcut. So here it is clearly explained how to get the ratio of engineers and workers by using the alligation process. So we have written the engineers first and then the workers. So below them we have written their average salary, that is 1200 and 500. So average of all, that is a median value, is written in the middle 800. So by subtracting 1200 and 800, we have got 400, and subtracting 500 from 800, we have got 300. So the ratio, by simplifying 100 in both, we have got as 3:4. So the answer is ratio of engineers and workers is 3:4. And not only for this type of question, so we can use this alligation concept wherever we need to find the ratio. So we'll see one more example. So we'll see another example, so which was asked in the previous exam. So we'll see how easily we can solve this by using the alligation process. So the question is, so gold weighs 19 times heavier than water, copper weighs 9 times heavier than water. So in what ratio they must be mixed to get an alloy, so which is 15 times heavier than water. So students used to find this ratio by many methods using more working. So but to avoid all that, so you can use this alligation process, and in a easier method or in a quicker way you can find the ratio. So by using this alligation. So as we did earlier, we'll write this gold and copper, and below them their weights. So gold and copper. So gold weighs 19 times heavier than water, and copper weighs 9 times heavier than water. So you need an alloy, so which is 15 times heavier than water. So write this 15 in the middle. And by subtracting 19 and 15, it is 4. And subtracting 9 from 15, it is 6. So now simplifying this, so we get the ratio 3:2. So now this gold and copper has to be mixed in the ratio 3:2 to get an alloy which is 15 times heavier than water. So in this question, they haven't mentioned which has to come first. So they have asked only the ratio. So you look for the answer, so which has 3:2. So in this case, they will not give us 2:3 and all. Suppose if they mention as gold and copper, it is 3:2. Or if they mention the question as copper and gold, so they will give the option as 2:3. So here you will have only one option which involves this 3 and 2. So in what ratio they must be mixed, that is the gold and copper. So they have to be mixed in the ratio 3:2. So now using this alligation process, we have found the ratio easily and quickly also. So by using all these concepts which we have seen so far, so you practice them well so that you score more marks in exam. Friends, at the end of this session, you will be able to solve problems in average relating to finding the missing term, missing two terms, finding the yth term, finding the individual value of a term, to find the present age of persons, adding a constant number to all terms, wrong entry questions, average of n terms in AP, average of n odd terms, average of squares of AP, addition of one term, exclusion of one term, replacement of one term, average of n multiples of x, find the average of x plus y quantities, find the average of p minus q quantities. So now we'll work out the questions.